Okay, hello everyone, and welcome to the activity for the design and fabrication of the vertical axis wind turbine as a part of your hands-on experience for the material and manufacturing engineering subject. As you know that the wind energy, as one of the fastest growing renewable resources, offers a clean and efficient solution. The vertical axis wind turbines are able to capture the wind from any direction. Well, unlike the horizontal axis wind turbine that need to rotate with the direction of the wind. They are relatively quieter operation compared to the horizontal axis wind turbine, and that makes them available to be used even within the buildings or over the top of the houses. The challenge in this subject is to work in a team environment and develop a vertical axis wind turbine that can generate the maximum amount of the electrical power with the least wind speed within a given time frame. The team size that you need to create is going to be anything between 1 to 4 students. The maximum number is 4. And the members can be in 2 different lab sessions. They don't have to be 4 from the same session because I know sometimes this could be difficult. The wind turbine that you need to work at, it doesn't have to be too complicated. We're looking for something simple, can be manufactured at the lab we have at UTS within the equipment that available for the students, considering the skills of the student. Some of the students have built some wind turbine earlier, as we understand, others are not. So just work on the model that you think is going to be suitable for your skills. So once again, it's a team-based construction. Students will form teams to design and fabricate the turbine. The testing rig will be provided to automatically run and test the turbine. So mainly is going to be a big duct. The length is 3 meter. The height is zero point 0.9 meters. Sorry, zero point 0.8 meters, and the width of zero point 0.9 meters. The wind turbine will be sitting somewhere in the at the end of the turbine or the duct, and the fan will be generate the wind at different velocities. The test rig is not finished yet. We need to add an air straightener in the front to change the rotation of the air to a straight line wind stream. At the end, the highest RPM recorded is going to be the winning model. So we're not going to generate electricity, but we're going to test the RPM value for the wind turbine. For technical support, the student can access to technical staff for advice and assistance, and we will be available during the lab sessions and the predetermined remote sessions if you need an extra help. The team makeup, the student may form the teams with a suggested maximum number of 2 to 4 students. I said 1 to 4 is the minimum number is 1. The maximum number of the students can be 4. The team leader will create and identify the document the roles of the individual team members. Without actually organization your team, the project not going to be run smoothly. You can check the wind turbine project outline document for the material to be provided. Mainly, we're going to provide a material for the basic design, and we encourage using the materials that have been recycled from the other subjects or from last year wind turbines. The optional procurement can be also available where you can bring your own material for the modified designs. The tool access, the crew can utilize the equipment and at the MDS workshop where we can do the manufacturing there, and we can do the assembly and the storing of the items at the lab at level B1. These are the suggested model we have. Away from the dimension, I provided the access for the links to access all these designs. You don't have to stuck with their own dimensions. Once again, we said that our dimension is going to be The shaft size about 500 millimeters. The maximum diameter can go up to 0.6 meters. And what you need to provide us is we don't need the base. We just need to have the turbine over the shaft. I mean, this base is mainly for the testing. That's what we want you to provide us. The stem with the turbine fixed to it. Even for this design, actually, you don't have to start with the dimensions. We don't want these dimensions. These dimensions are quite small, 350, and we have much higher value you can utilize. The wider the wind turbine is the better capturing for the wind, because what's happening is that the length of the arm will be increased, and thus the torque is going to be much better. Now, once again, the dimension limitation we're going to have that the maximum height is going to be 500 millimeters. That's including the shaft. That's mean this height is going to be within the limit about 400 to 430 millimeters. The width, maximum width is going to be 600 millimeters. So what to submit? What we need you to submit is going to be the shaft and the turbine attached to it. Once again, the turbine section is going to be anything between 400 to 430 millimeters, while the shaft end length is going to be anything between 70 to 100 millimeters. The diameter at the end should be 12 millimeter diameter. Okay, so the wind turbine over 12 millimeter diameter shaft at the lower end. For this one, you can see that this part has been machined to 10 millimeters. You can find many of those shafts available for you in the lab. The total length of this shaft is about 400 millimeters, so you can utilize them by using the turbine that can be fixed and at one point, not built over the shaft entirely. Some of the frequently asked questions from the yesterday's session. What are the dimensions of the testing tunnel? So we said that's going to be 0.8 meter for the height, 0.9 meter for the width, and 3 meter long. The power of the fan, this fan here at the end, can provide 1000 watt, but definitely the speed of the testing is going to be constant, or there will be a variable speed. But I can have variable speed on this fan that can take us from about 0.5 to 1.5 meter per second. But this will be changed after adding the earth straightener in the front, which is going to be affecting with the speed. During the test, the wind speed is going to be constant. How the electricity will be generated from the wind turbine? No electricity will be generated. We shall count the shaft RPM. Okay, we'll count the shaft RPM. The dimension of the shaft and whether the shaft is going to be provided. The shaft will be provided with 400 to 500 millimeter length, 12 millimeter diameter. Some of the recycled shaft has been machined down to 10 millimeter at one end. You can simply use the 12 millimeter diameter at the bottom for your design. Now, more questions are, do we have to prepare the base generator or the gears or extra? The answer is no. Just get the turbine over the shaft. When will we be able to test the wind turbine prior to the actual testing in the week number 10? And when can we see the testing arrangement? This is a complicated question. The rig will be ready in 2 weeks' time or less, but we cannot actually bring it to the lab before the testing week because the lab is shared area between multiple subjects, and we may not going to be able to have the space to bring the wind turbine to the lab. But we will try to make an arrangement so the student can pre-test the lab, or we can bring a fan, the extra fan we saw near the test rig, and the student can check if their design is workable or not. Now, some students asked to see the testing arrangement, get details before the hand, and have an access to it so they can have the proper context. Now, the dimensions are 0.8 meter height, 0.9 meter width, 3 meter long, and once again, the dimension, as we mentioned earlier, is going to be the maximum length of the shaft is 500 millimeters. You need to leave a part of it anything between 70 to 100 millimeters to hold the shaft on the testing arrangement, and the width is going to be 600 millimeters. Just work within these dimensions. Now details about the competition: what is the reward, what are the criteria, and when it will going to be taken place. This question will be answered on time. Just leave it as a surprise for you. The criteria is we are going to check the RPM value for the shaft due to the movement of the wind turbine. The highest the RPM is, this will be the winning design. When is going to be taking place? Between week 10 to week 12. So we're going to start to get the winners from each session, and then we're going to take these winners to compete for the finale. And the winning team is going to be number one. They will get rewarded somehow. Okay, thank you very much, and see you later. And by the way, if you have any question, just send us a messages, and we're going to be more than happy to answer those.